Hi, this is Joshua Van and Drew Galloway. We're Benzies Survivalists, and this is our final project. Uh, Drew, what's going to be your first topic that you're going to talk about today?
My first topic is going to be measurement and the density of numbers and the law of large numbers.
Okay.
So,
What Sorry. What is the relativity of size?
well, the relativity of size, it has to do like a lot with the and mostly in like dumber terms, it's the measurements. So without the ability to measure size, it would be difficult for scientists to conduct experiments or form theories. Not only is measurement important in science and the chemical industry, it's also essential in farming, engineering, construction, manufacturing, commerce, and numerous others occupants. Also, like, and when you get a signed number, it can be too big or it can be too small. And once it becomes too big or too small, we put it into a thing called scientific notation, uh, as you can see here, which is a mathematical expression used to represent a decimal number between 1 and 10 multiplied by 10. So you can write large numbers using this. Also, the reason why size is so important in knowing it, really you can also use it for realizing how small something is. Like if you take our world or our Earth for chance and you put it up against Gomez's hamburger, you'll realize that our Earth is actually way much smaller than Gomez's hamburger.
That's neat. All right. What is the relativity of speed?
Well, speed is a measurement of how fast an object moves relative to a reference point. It does not have to have a specific direction. It's considered a magnitude, or speed can be figured by the formula speed equals distance over time. Here, we used for the Excel report that we created, we used we wanted to find out how fast that we were actually moving. So the ones that I created, if you look at our Earth speed, is actually 6,700 miles per hour. And if you look at Andromeda speed, they're 250,000 miles per hour. So we're actually, if we take off running, we could be running like a 4.4, but yet we're still running actually really, really slow.
Yeah, that's like
Okay.
that's neat. Okay.
What is your topic that you're going to talk about?
Let's see. My topic is population samples and the probability and distribution.
All right. Can you discuss the differences in standard deviation given the two population and samples analyzed, height of Army recruits and the height of mall shoppers?
As far as with the Army recruits, the difference between the Army recruits is it's a small sample representation because it's going to be either just men, just women. And as far as whenever we took and looked at the Army recruits, our median was 74. Our mean was 72, meaning that that was the average. The standard deviation was 4.03, and the coefficient of variation was 0.05 as far as with the Army recruiters. And the heights of the random mall shoppers, there was a bigger difference because these were a mixture of men and women and of various ages and heights. And so the median was 58. The mean was 58.88, and the standard deviation was 14.07. And with the mall shoppers, this was a population sample because it wasn't just a small group. It was actually multiple groups as far as different ages, different genders. And with with this, we can kind of see the difference in when you pull a population sample versus a small group sample.
Yeah, I heard most Army recruits are around like 6 feet tall.
72, about 72 inches, so that's pretty close.
Can you show us how the scatter plot trend lines width of the box and whisker plots correlate to the size of the standard deviation and the coefficient of variation?
The as far as with the coefficient of variation, the ratio of a standard deviation to the mean. So our mean was 72, and our first quartile was 75. Our third quartile was 74, or about a 74.5. And so as far as whenever you look at the box and whisker, it takes that, just the quartile, takes and shows you the difference in between each. And then with the mall shoppers, 60 was our median, 77 was our quartile 1. Our quartile 4 was 47 or 44. And then if you look at the box and whisker, it shows that as far as the 47 being your fourth quartile and your first quartile being 77. So, and all of these graphs were all made in our Excel reports.
All right.
Let's see. All right, Drew. What is the meaning of an isotope?
An asymptote is a line that continually approaches a given curve but does not meet any infinite distance. The asymptote will be used to describe the behavior of the functions near its asymptote. Has a slope that is non-zero but is infinite, such that the graph of the function approaches it as x tends to be a positively infinite, or it could be a negative infinite. So it could switch from one side of the axis to the other side of the axis, as long as it's still not meeting at some point.
Okay. That's neat. Uh, what what's the number of times any amount can be divided into more parts?
So a number can actually be divided into an infinite amount of numbers. Once it gets to a certain point, we have to we actually use this little e that you can see from our Excel reports that we've made, and it will describe. It's kind of like the scientific notation, as I explained before. When it gets to a certain point, that we use this e uh, to represent the number. And so when you have e, you'll have the 0.365. That's how many zeros that's going to be behind it, so that you
Okay.
can describe the point and still make it fit on the page, because some numbers are so small that it can fill up to 10 pages and still keep going.
But that's definitely interesting. That's kind of weird.
Uh, uh,
Okay.
yeah. Can you discuss the probability of belonging to each age group and using a distracting device while driving and create a second the device while driving?
Well, here looking at a we're looking at a the chart that we're looking at actually tells the percentage of the people who actually use cell phones while handheld cell phones while driving. And as you can tell, the age of 16 to 24 was in 2007 was a lot higher than it was in the 2016. And then if you look at the age 25 to 69, same. It had a less of a downward slope than the previous. And then if you look at the age 70 and older, it pretty well stayed pretty consistent, because I mean, at that age they may not be driving as much, and so you won't have as big of an age group to sample from, because of the fact that there's not as many people uh, to ask. Where whenever you look at the 16 to 24 age, uh, I mean, there's a lot more people that you can sample from, but then you also have uh, the younger in age. They're not as responsible and don't necessarily have the experience to know not to use cell phones while driving and other activities.
All right. Looks like the young kids know how to text all the time.
They do, but thankfully, looking at that graph, it at least shows that they're
Can you
starting to
show
do it
us
more
how the scatter plot trend lines? Oh, yeah. Can you show us how the scatter plot trend lines, width of the box and whisker plots, and width of the bell curves collaborate to the size of the standard deviation and the coefficient of variation?
As far as with these, first thing, I chose this age group because it's actually the age group that I would fall in. So, but these are graphs that we did make in our Excel report. And as far as, I mean, if you look at the scatter plot, it pretty well shows the the number of people that have used cell phones. And then if you look at our mean, our percentage is 4.9. Our median is 4.9, and then our standard deviation is a 0.9, and then our coefficient of variation is a 0.17. And if you look at the, we have a bell curve over here on the right, and the bell curve, the peak of the curve is always at the mean, and then the standard deviation, it goes out to the left and the right, and it will take and show you the standard deviation, which is the 0.9, and the box and whisker, it takes and breaks down as far as the information just in a different way. Okay. All right. How do graphs and charts report the same correct information, but tell different stories?
Is that?
Oh, I'm sorry.
Yeah.
Yeah. No, I'm on the right one. Yeah. Hold on. No, I am on the wrong one. I'm sorry. That is my fault there completely. All right. Discuss the theoretical and empirical probability. And so what is the, and I'm showing the wrong chart too, am I? No?
No, you were on the right one. It's just the wrong
I asked the
question.
wrong question. I'm sorry. Trying to get us all confused here.
The empirical probability of an event is given by the number of times the event occurs divided by the total number of incidents observed. Theoretical probability, on the other hand, is given by the number of ways the particular event can occur divided by the total number of possible outcomes. A theoretical research is the one which is hypothetical, unlike the theoretical one, or unlike the empirical one, which is based on observed and measured of phenomenon and developed knowledge from real experience rather than from a theory. So basically, the difference is one is real and one is just based off what has already happened. So if you look to the one on the left, that was a number of dice that we did theoretically, and
Okay.
we guessed that it would roll this many times. And then the one on the right is the one that we did empirical, and that was how much. That's what it actually rolled.
Okay. That's neat. Okay. What is the law of large numbers and the central limit theorem?
All right, the law of large numbers is a principle of probability according to which the frequency of events with the same likelihood of occurrences even out. Given enough trials or instances, as the number of experiments increases, the actual ratio of outcomes will converge on the theoretical or expected ratio of outcomes. So basically, basically what it means is the more times that I roll, the more likely I am to get the one I'm looking for. So if you look at the top graph here, the top graph, that's the least amount of numbers. But if I keep rolling, then I'll have this many chances to actually roll like a 3. But if I do an even number, like the one on the bottom, if I just say even numbers, then I have more chances to actually get what I'm looking for rather than not having them at all.
Okay. That's neat. That's a good thing to take to the casino with you.
Oh yeah.
Okay.
Leave a mother. All right. Can you discuss the probability of belonging to the percent of the population with a healthy BMI score?
All right. The probability of having a healthy BMI for me is 11%. Now, depending on if you look at these two charts below, whether you're American male or American female, the percentage is different. As far as with the mean would be, or sorry, the about 14.1 or 34.1 would be the would be as far as pretty close to the average for most Americans. And then whenever you take and start moving away from as far as American women, whenever you start working your way down the bell curve and start moving out your standard deviations, it takes and starts having a lower percentage. And same with the men. Your BMI score may, like mine, I ended up with there's a 13.0% chance that someone would have the same BMI score as what I do. And this kind of was the other lines that are on here are my family members, as far as my wife, my son, stuff like that. I mean, my daughter. And it shows the percentage of other people or what their percent chance of being the same BMI. So with both of my sons, there's a 4% chance of being the same BMI score, where my daughter, there was a 34% chance.
Yeah, when we did this, I found out that me and my dad had the same BMI score.
Oh, yeah? Yeah. In a way, I don't agree with how the BMIs are, how you get the BMI score, but, I mean, it's one of those things. I mean, so.
Yeah. Can you discuss your Z-score and percentile rank relative to the two other people you choose?
Okay, your Z-score is the number of standard deviations from the mean. And the Z equals the value minus the mean divided by the standard deviation. And as far as with me, my BMI was 35. So that put my Z-score at a 1.27, which means that the probability of a random person with a lower BMI is 89%. and the probability of a random person having a higher is 11%. So because of my z-score being so high, and because my BMI was so high, that made it to where there was a bigger percentage. My wife, her BMI was 29, so her z-score was 0.21, which meant that 58% of people were lower BMIs and 42% were higher. And then, I mean, you can kind of look at my son. His BMI was 22, which he had a negative z-score, negative 1.48, meaning that only 8% of people were lower than him and 92% were higher. So as far as, I mean, the z-score just kind of gives you the probability and helps you determine on like this chart that we made, the probability of someone weighing more or less. All right, Drew. Looks like we're switching topics now. What's your next topic you're going to be talking about?
It's going to be misleading and false data reports and assessing resources and information.
So basically, I'm actually going to be asking you the question I tried to earlier. How do graphs and charts report the same information but tell different stories?
Okay, well, what we have here is two sets of graphs. But if you notice that the first set does not start at 0, well, it makes it seem that it's way much bigger than what it actually is. But when we set it to 0, like the one on the right, you will notice that there really isn't that much of a difference. And the big companies love to do this type of thing so that it will make them make their product look way much better than all the other products, when in actuality there's not much of a difference. But also, if they show you this and you start to believe it, that's when they want to start jacking up their prices and things like that.
Okay. Yeah, it's always funny how they try to skew the numbers so it makes them look better than what they makes it look like there's a dramatic difference, even though it's so small of a difference. All right.
Also, if you notice that the one on the left.
Okay.
The one on the left is all in 5%, but when we actually changed it all to be raising up from 0 to 1 to 2 to 3 to 4 to 5%, that's when you'll notice that it's actually not much of a difference.
Yeah, the difference is only like tenths of a percent. I mean, they're just little small increments.
Little bitty things.
Yeah. All right. How do charts and graphs tell us lies to mislead people?
All right, this is kind of related to the first part too, where they're kind of like misleading you. The only difference is that this time that they're flat out lying to your face. So this is different from the last misleading information that I just showed you, because in this one is a big lie right to the face. The last one actually has some truth to it. When we plugged it in, the number for that one, they were correct. It was the correct data. Whereas the one is not. If you look at the first picture, that we created in week 2, you will notice that the Carter says that it only takes up 4.5% of the circle, but when we actually plug it in, it truly takes up 13.7% of the circle, which is a huge difference rather than 4.5. It's like buying a pickup and getting a semi.
Yeah, that's a big difference. That definitely is.
Yeah. Josh, it looks like you got a new topic. What's your new topic?
All right, let me find it and I will talk about it. All right, looks like I'll be talking about personal, state, and federal finances.
All right. Can you discuss the outliers that keep the distribution of America income from being normal? It is okay to
As far as like on this one, the what you can see is that this one is skewed to the right, and the outliers, there's a few throughout. Not very many, but I mean, no chart's going to be 100% accurate. But this,
right.
but with a chart like this, it'll never be normally distributed. And if you look at the different percentages, you can kind of see every so often you have where stuff just kind of jumps up a little bit, and it's only because we're trying to take and put everything into a percentage. So I mean, whenever you go and oh no, kind of lost my train of thought on that one. But yeah, the if you look at it, the median income is looks like $49,400. So go ahead and move on to the next one. Like I said, I kind of lost my train of thought.
Can you show the struggles of starting a business and relate the distribution of American income to the struggles of starting a business?
Well, as far as like starting a business, the problem that you run into whenever you first get started is you have to take and overcome the you have to take and uh, hit that break point, or where you actually start to make money. And like on this graph here on the right, it shows that whenever they first started out, they actually were losing money because they had to start producing more products before they can make any profits. And that's kind of the same whenever you look at the chart on the other side, or on the previous one. The way this chart actually shows it is that there's a lot of people who make very little money, and then as you start making more and having that extra income, you start getting a smaller percentage because of the fact that it's harder for people to make that money than it is for them uh, to actually get past that point to where you're making a profit or you're living easy, stuff like that. And then on the whenever we done the Excel report, we also took and we have an equation right here that shows how to determine what the profit according to sales is.
It looks like when I start a business, the first thing I do is lose money.
Yeah, unfortunately, you do because you have to have enough product to actually start selling. And once you start selling, that's when you start making money. But until you reach that point, I mean, you end up losing more than whenever you first start out. But the nice part is once you finally get started, you can actually make money and continue to make money. So, all right. Looks like we're moving on to your task number 2. Uh, what is the probability of guessing uh, multiple choice test? Is that right?
Uh,
No, that is wrong. I done it
no,
again.
it should,
I done it again. I'm sorry. Uh, data reports showing the correlation between GMO and crops and various diseases. Uh, what's the correlation between them?
all right. Well, if we take the graph we created in week 7 with the data that we got from the internet to it seems like there is a possibility, given the fact that as kids eat the GM crops through the years, the number of kids with autism increases as well, which makes it seem which makes it even more believable because they actually put the dates on it that they are happening around the same time period. After looking at these graphs, I believe that we should have like a better investigation through the science aspect of it so that we can see all the facts and judge them for ourselves.
Okay. Yeah, the graphs doesn't make it look very good.
Yeah.
All right. What let's see. What is the data reported by the FDA?
Well, with the FDA, also with the graphs that we created in week 7, uh, if you take both of these, uh, we got from the internet, we found out that the FDA does not agree with this. The FDA regulates the safety of food for humans and animals, include the food produced from genetically engineered plants. From those plants, they have to meet like the same food safety requirements as food as the same food as regular crops, not just not or yeah, like regular bananas and stuff like that. So not all of them have to be genetically engineered, but they still have to meet the same requirements as one that as a regular one. But they also say that early farmers developed crossbreeding methods to grow numerous corn varieties with a range of color, sizes, and uses. For example, the garden strawberry that consumers buy today results from a cross between a strawberry species native to North America and a strawberry species native to South America, which means that the crops may not actually be the problem.
Yeah. Yeah, I always thought it was neat that bananas are actually just clones of each other. The bananas that we
Yeah.
actually get in the store, that's not what they actually look like. That's not real bananas. They're just a clone made by genetically modifying or engineer breeding certain bananas just to be able to get something that's easier to consume for consumers. All right.
Yeah.
Where are we at now?
Okay. can you discuss the inequality of wealth in America? Yeah.
All right. As far as that goes, if you look at the table on the left, it shows the households as far as the wealth in America, and as far as uh, like 1% of the wealth, or as far as the American wealth groups, actually own 35.4% of the actual U.S. wealth. So I mean, that pretty well shows that there's a smaller percentage that has has increased money, like 40% have negative 0.9%. So I mean, you're looking at 40% of the actual households in America don't actually have that much money. They actually may even fall within either lower middle class to even poor, where only 1% actually has 35.7% of the wealth. So 1% has 35% of the money that's in this country. And if you look at the stacked bar chart, it kind of shows the difference as far as the amount of households that actually have the money versus the households who own the money, or the groups that have the money versus the ones that actually own, or I don't know, it's kind of weird trying to explain it. So
All right. Can you tell us where all of our American tax dollars are spent?
well, if this is a chart that we had to take in, or a pie chart that we made, and it kind of shows as far as whenever you go into the look at the government where they actually spend the money, and it shows as far as like Social Security is 0.24%, and then hold on. Yeah, and it just kind of differs. I mean, we some of our tax dollars go into science and medical research. Some's into non-security. Some's into goes to the military. Some goes to education. I mean, it just basically is. Whenever you look at the chart, I mean, there a lot of it goes into different things to help benefit the country.
I've always wondered where my tax dollars been going.
Yeah, and sometimes, I mean, sometimes you wonder. Like it says that transportation goes in, and if you live in Arkansas, you know our roads aren't that good. So
Yeah.
the government doesn't help us. All right, we are. All right. If I can do this without messing it up this time. What is the probability of guessing on a multiple choice test? Because
Yes. So in order to do that, we had to do an abdominal experiment in order to find out the probability of getting that good grade, which we did with the data from the internet. But we had to follow the rules that you can see up on top, and we also had to find the formulas. And when I actually plugged it in order to find it, it turns out that you should probably study for the test rather than procrastinate, because it always ends up helping you at the end. I think there was like, if you completely chose C, it was only like 20%, rather than there's a 20% chance that you get a good grade. If you chose like B, then it's only a 10% chance that you're gonna get a good grade.
Yeah.
But if you actually study it, there's always like 100% chance that you'll
Yeah.
get a good grade.
It kind of funny story. Earlier, I had to take a final to be able to be certified for wine tasting, and that was one of the jokes that they made was no matter what you hear from everyone, choosing C doesn't always mean you're going to pass the test. So that kind of works. I mean, I could see it. All right, and then
I've always heard that.
what's that?
I'll go ahead.
Oh no, you were saying that you always heard. What was it?
I was gonna say, go ahead with the question.
Okay. What is the expected outcome of buying lottery tickets?
Well, if you take a look at the graph here that we had to make with the data from the internet, if we put in so if you look at the first line, the expected outcome of it is going to be where you lose $3.86 because you actually put in 5, but the probability decimal brings you up a little bit, and you actually have like a 77% chance of losing the lottery. But to win the grand prize, you actually have a really bad odd. It's really like 0.0007%, which means that your expected outcome is going to be like 7. Your chances of winning is only like 7%. So if you really look at it, it's not really worth it.
Yeah, that's one of those things I've never really gotten into. Never really got into the hype of buying lotto tickets.
I've honestly never been off to actually watch the lottery. So I just never did my chances.
Yeah. All right.
All right. Can you discuss the different ways we can pay taxes?
As far as that goes, I mean we pay state, we pay federal, and then there's also whenever you take and actually file your taxes, there's different ways you can file as far as filing jointly, filing married, filing jointly, or head of household. And then but as far as like with like here, we took and made some different charts to determine what if you had to pay taxes and you claim to be single, what your annual pay was, what the amount of taxes you actually had to pay, and then what the leftover is as far as after you paid your taxes. Like on this single, it looks like if you're single and you pay your taxes, you're going to pay right around 50,000. uh, as far as you'll get paid 50,000, and then looks like right around 18,000 is what you'll pay in taxes, and then that'll leave the rest as far as for what you can use for the rest for anything else you need. Your leftover, which will be looks like right around $32,000. So
It looks like I need to get married.
yeah, yeah, you definitely don't get much back whenever you're single.
Um, let's see. Can you tell us how tax brackets work and how the percent of taxes owed changes depending on your income and the way you file?
As far as
Or
that goes, I mean, the taxes owed is all determined by the percentage. Whenever you take in, like here, if you're married but filing, let's say married and filing jointly, you're going to be paying, or you're going to be deducted 19%. So you're going to end up paying $11,355 if you make an annual pay of 50,000. And basically, there's just a percentage difference. Like whenever you take in, uh, let's say you take and get a raise at work, you get paid 52,000. Well, your deduction didn't change because it didn't change your tax bracket, but you did have a little bit more taxes paid, but it wasn't enough to really affect a lot. Now, whenever you're, let's say, if you're filing head of household and you take and get paid 50,000, paid and get a 19% deduction, you're going to end up paying 10,000 and $10,810 in taxes. Well, if you take and get a new pay just being up to 52,000 and you move to that new tax bracket of 29%, that's going to end up making it to where you're going to end up paying $20,972 in taxes. So it basically, whenever you do pay your taxes, as long as you're not changing tax brackets, you won't see that much of an increase. But if you happen to change tax brackets and you go up a percent, that's whenever you'll drastically see a difference whenever you take in whenever you a drastic difference in the leftover amount of money that you have.
It's good to know when I file my taxes.
Yeah. I do agree there. Let's see. Where are we at? I believe we are on a new topic. What do we got for us?
It's our last and final topic, the probability of an event given a population and a sample.
Okay.
All right. Oh, yeah.
And what is the probability of being an obese American and being an obese American with type 2 diabetes and high blood pressure? Yeah, so what is the probability of being an obese American with diabetes or type 2 diabetes and high blood pressure?
Well, with this data that we got from the internet, it shows the possibility of being obese, having type 2 diabetes, or having high blood pressure. And it shows the possibility of either just having just two of them or having all three of them. When looking at this chart, it does not mean that you will have one of these. It's just showing the possibility of having them. So that actually having all three of them is going to be 8.5%, which 27.7 million people already have in America. But just having if you look on there, if you're just obese and have high blood pressure, then this is only 16.1%, which is 52.5 million people in America.
Huh. That's definitely interesting information to think of. What your percent chance of, if you are obese, what type of different diseases or not diseases, but what ailments you could have from being obese, whether it's diabetes, high blood pressure, different stuff like that. Okay. What is the probability of being an obese American, and how's that dependent on the population of where you live in the U.S.?
Well, this chart and map shows us the possibility of having all three based on where you live. Like if you look here on the map, it shows you that if you live in Arkansas, you have the higher percentage of being obese, having type 2 diabetes, and having high blood pressure. Luckily for us, though, we have Miss Benzie, who has makes us make an awesome dietary plan so that we can lower our chances of having all three. And if we get more people to do the same, then we could change the percentage of our state to be one of the least possible states to have all three.
Yeah. Yeah, the dietary plan was that was actually kind of interesting this going around, because I'm also taking nutrition, so I had to do it for 2 classes. The difference was I had to actually come up with the meal plans in nutrition, where with Miss Benzie, I just had to come up with basically all the mathematics on how it was going to work. It was different.
All right. Well, it looks like you have a new topic as well.
Let's see. It's like I do. I'm going to be talking about interest, investments, and loans.
All right. Can you discuss the linear growth pattern of the simple interest line? Yeah.
If you look at this chart as far as of occurring interest, the simple interest is the line that's in blue, and the way we determined it was by this equation. The interest drew a blank. The interest by the percentage rate and time. And but yeah, we if you look at the simple interest, I mean, you can tell that over time it stays the same, but you really don't gain a lot of money over the years. I mean, it takes 10 years to basically get up to $5,500, and I mean, you started out with 3,500. So I mean, a simple interest is nice, but you really don't have that much risk. It just doesn't accumulate very fast. Don't really get to make much money.
see. Where'd it go? Can you discuss the exponential pattern in the compound interest graphs?
Well, the way we did determine our compound interest is by the equation there on the left. And as far as with the exponential growth, if you look at the orange and the gray, they're both using the compound interest. So if you notice, compared to our simple interest, whenever you take in about the 4-year mark, it actually starts to have a curve up, and that ends up showing that you can make more of a profit, or you can have more interest, or that will be in your pocket versus the simple interest. And honestly, if I had a choice, I would probably pick compound, but it also has its side effects. So, yeah. Where are we at? We are right here.
I dropped my pen.
All right. On the data of the impaired driving in the U.S., okay. What is the data for impaired driving in the U.S.? And what is the probability of being on a rural road versus being in the city?
All right. If you take a look at the chart on the left, it shows you which substance affects you more while driving. You will notice that the strongest one is regular medication. The alcohol is actually a second, but when you watch TV, drinking and driving is the most causes of wrecks. The graph on the right shows that you are more likely to crash while on these substance on a rural area or rural road rather than a small town road. And this is probably because there's less people in a small town on the small town road. Just basing it off around here, a lot of people, since everybody knows everybody, they don't really have to go home. They'll probably just stay the night at that person's house because they know them. If you look there, the orange one, the really, really long ones are the rural roads, and then the yellow ones are the urban ones. Okay. But the little bitty gray ones at the bottom are going to be the small town ones.
Huh. That's interesting. All right. Let's see. What is the data involving poly drugging in the British Columbia, and which U.S. population in British Columbia I'm not sure. Hold on. My question's still working. It's working its way out. What is the data involving drugging in British Columbia? And what U.S. population in British Columbia? And then what is the probability that it may or may not represent?
Well, this right here is basically what they did that shows you the probabilities and stuff. Like if you were to drink alcohol, you're 9.7% more likely to crash, and uh, but the 106 9.7 is that whole yellow circle. The British Columbia found that out of 1,097 drivers met inclusion criteria. 60% were at the age of 20 to 50 years old. 63.2% were male, and 29.0% were admitted to the hospital. We found alcohol in 17.8% of drivers. Cannabis was the second most common recreating drug. Cannabis metabloids were presented in 12.6% of the drivers. Yeah.
Yeah,
That was a tricky question.
yeah, that was an interesting question. All right, what do we got now? We got should be this one.
Yeah. Can you discuss the difference between a house cost and what you pay in the end with interest and create? Yeah.
Okay, as far as like whenever you buy a house, like on this one that we took and done on our Excel report, we bought the house for $120,000. Well, we had to put a down payment. Our down payment ended up being $9,600. So that means that as far as principal, what we actually started out with was paying $110,400. And so once we got to that point, then we have to add our interest rate for our home loan. Well, whenever we took and let's say whenever we took and got our home loan, it was a 5% interest rate. So then over a 5 years of paying for the house, our monthly payment is going to be $2,083.38, which ends up being to where for those 5 years we paid a total of $25,061. So then of that 25,000, 14,603.65 or 5 cents was in interest. And that basically whenever you take and get your loan, that interest is going to add to the amount that you have to pay for the house. It doesn't add to the value of the house, but it's just what you're going to have to pay. And if you look, if you paid for the house for 30 years, your house payment gets lower because you're not paying as much interest anymore. But the interest that you've already paid is so much that you basically almost double. Well, actually, you do end up doubling by the time you get your house paid off in 35 years in interest what you initially asked for when you bought the house. And then we also showed this kind of breakdown in a chart that's right above.
All right, man. It looks like it's expensive to buy a house.
It'd be nice if I had the money to pay a house off directly, but
oh yeah,
banks have to make money somehow. Their interest is how they do it.
Can you show the 3 different options for paying off your house if you pay 0 extra, 50 extra, or $100 extra?
Okay, on this slide, I have where we took and showed on our Excel report where we took and showed the monthly payment. We took and paid no extra. We said that, hey, we're going to pay this house off in 240 months. Well, without paying any of it, as far as any extra, we end up having to pay $174,960, and of that, 64,560 is interest. Well, we decided to go ahead. Hey, we'll stop eating out. We'll put $100 to it now extra. So instead of paying 179, we're paying 729. We're paying 800. Sorry, I'm messing this all up. Instead of paying 779, we're going to be paying 879. And by paying 879, we actually cut down the amount of months that we had to pay from 240 months to 194, which actually saved us because instead of paying $174,660, we only ended up having to pay $160,226. So that saved us almost $14,000 in interest, which is a lot better. I mean, that's money I would rather be spending on something else than paying a bank to give me my loan. Give a loan.
Yeah.
All right.
The last and final task.
Yes. If I can find your task. There it goes. I think this is it. Yep. Okay. Yeah. All right. Task 3. What is the probability of belonging to the percentage of the population with a healthy BMI score?
The BMI score? I think that was your question. Mine should be about the president.
Hold on.
Political parties.
Yes. I done it again. I don't know what the crap's going on today. All right. What's the probability of approving the president depending on which party an American belongs to? So I guess their approval rating.
Yeah. Have you ever wondered how many people in politics actually approve the president? This pie chart is loaded with data that we got from the internet. It was actually surprising because I didn't know that any of the Democrats approved of him, but it shows that 8% actually know actually 8% of them actually do approve of him. But I lost track. Now, but I do know that 90%, or I kind of already knew that 90% of the that 90% of the that 90% disapprove of him, because we hear it all the time on the news, and then only 2% made no comment. But I was actually shocked when I saw that. But it was also nice to see how many people do and don't approve. But it's crazy to think that people from his own party don't approve of him.
Yeah. All right. And what is the probability of being a woman or man in different branches of the U.S. military?
The U.S. military is mostly made up of men, but nowadays we can find women in the military as well. If you look at this chart that I made for Week 12 Excel Report 3, you will see the probability of being a man or a woman in the different branches of the military. Like, for instance, what is the probability of being a man in the Army? If you look at the second row right here, there's actually a 37% chance of just being a man and being in the Army. But if you're a woman and you're not in the Army, you can still be in the Air Force, the Marines, or the Navy. And there's actually a 33% chance of being a woman in 3 of those. And then, or you could just take the Marines out and be a woman in the Army, Air Force, or Navy. And there's actually a 93% chance of that happening.
That's some neat information. All right.
Can you discuss the different cost of living in your chosen states from your Module 2 financial report?
Okay. As far as that goes, what I picked were, I picked if I decided to become an executive chef in 5 years, and if I moved to New Orleans, Las Vegas, or New York. And if I moved to New Orleans, I could have a salary of $67,389. Or if I ended up choosing New York, I could have a salary of $82,136. But when you live at the different places, New Orleans, I can buy a house for $187,100. Go to New York, $662,100. So then you still got your cost of utilities, your groceries, your health, transportation. Most of the stuff really, besides the housing, isn't that big of a difference. Cost of utilities, I mean, there is a difference from $87.30 to $150.50. But also, if you look, New York, there's actually a lower property crime rate. So 25.9%, where New Orleans is 49.6. But if you go to violent crimes, New York violent crime rate is 55.3%, and violent crime in New Orleans is 71.5%. So there's a lower cost of living in New Orleans, but there's also a higher crime rate and a higher violence rate. So that's one of those, it's always different to have to weigh out your options on where is going to be best for you in 5 years. And Vegas kind of sits right there in the middle in between both. I mean, it does have a higher violent crime, and it does have a higher property crime versus New York, but the stuff isn't that much more expensive than living in New Orleans.
I definitely wouldn't mind living in Las Vegas.
No, I got a buddy who lives there and he loves it. So,
can you show the city you chose and discuss why making more in one city doesn't always mean more leftover income because the cost of living may be higher?
Well, as far as like same. I mean, this slide shows where we made the budget for New Orleans, for Las Vegas, and for New York. And just like on this, I mean, the monthly income was $5,615.75 in New Orleans, where in New York it was $6,844.67. And so if you notice that, I mean, housing cost is one of the big differences between New York and New Orleans. But then, I mean, car payment it's a little bit more expensive in New York. Water bill's about the same. Electric, most of it's about the same until, I mean, you got maybe a little bit more credit card debt because you're going to spend a little bit more in probably doing extra stuff, or like here, groceries is more about $100 more in New York than it was in Vegas, or than it is in New Orleans. So ultimately, by the time you take all of your expenses, in New Orleans, it would be $3,497, where in New York it would be $5,665. So that would only give you a difference of $1,279.67, where in New Orleans you would have a difference of $2,118.75. And then, like I said on the previous one, Las Vegas just sits right there in the middle. I mean, it doesn't take much more. It doesn't really take much more away from you than New Orleans did, but it just has, like New Orleans, a little bit more crime. So it's one of those. If I did have a dream job, I mean, my choice would probably be Vegas, but I mean, you never know.
Man, I've never seen a cable bill at 56. I get all the sports packages, so it's kind of up there.
Oh, yeah. I think whenever I was doing this, I was kind of just thinking kind of like the way I do now. I just use Netflix. I use Hulu, so I pay like $56 because, I mean, both of them aren't very expensive. The internet's where I pay all the money because I don't actually have to pay cable.
So. Man, that Netflix though, it really is. They got some interesting movies on there.
Yeah, well, and I went with Hulu Live because it has live TV now, so it's like, hey, might as well save some money where I can.
Yeah.
But this has been our Excel report, our final Excel report for the semester. And it has definitely been a long semester. It's been a fun semester. I mean, we are Benzie survivalists after all.
Yeah.
So
we barely made it through, but we fought to the end and finished out.
Exactly. And that will be our report. Thank you.